Hi guys, my name is Sophie and I'm a data science intern at Knewton this summer. Today I'm going to be talking about Markov chains, and don't worry if you're non-technical because it's actually incredibly simple, and I'm explaining with the analogy of lily pads. So before we start, a few applications of Markov chains. They're really popular in a lot of data modeling questions, text generation, the predicting the weather, part of speech, tagging, finance, games, testing, and of course we can use it in education, like at Knewton. Okay, so imagine you have a pond and it's full of lily pads. Um, and you have a frog, and he starts off at some starting lily pad. And he doesn't really care about where he's already been. He's a frog. And he just wants to move about the pond. So we can think of the lily pads as states, and he's going to jump to the next lily pad with a certain probability. For example, if he's starting at lily pad A, he can jump to pad B or C with a different probability. For example, 0.4 and 0.6. Let's say that he jumps to pad B because that has a higher probability. I'm just drawing a smiley face. And then so forth and so on. It doesn't have to be two. It can be multiple. Sometimes the only transition you can take is just this one, for example. And with a probability of 1, you can only move once to this pad. So that's the basic visualization of it. But why is this useful? It's useful because we don't consider the history, and we assume there's independence. So where you are now where you go next is only affected by where you are now, and vice versa. So in this way, we can make a lot of predictions. In this example, if we know these probability transitions, which we can predict using our data, then we can predict where the frog is going next. In the case of weather, for example, if you know the weather today, you can try to predict it tomorrow. So that is an example of Markov chains.